You've learned the basics, created simple expressions, explored intermediate tools, and mastered advanced concepts. Now you can build a multi-expression rig from the ground up. Let's go over a few important questions to ask yourself. Question 1. What are the rig's requirements and what parts need to move? This is a great question to ask yourself before creating any expression. Before you start, you should think about the composition structure and elements. Some other good things to consider: what are the specific effects or plugins that the rig will rely on? Is there a smart parenting structure that will make expressions easier? Based on the answers to these questions, you get a better sense of what you're building and how expressions can help the setup process. Question 2. What values should be automated and what values should be keyframed? You can use expressions to automate tasks, but it's easy to forget how useful keyframes can be. Automation can become inefficient and unnecessarily complex if you're not careful. You can also ask questions like, what are the input values and how will they be linked to the output? Are there properties that will dynamically affect the value of others? As you answer these questions, connect the dots and imagine the foundational structure of the rig. Question 3. What are the most important properties to start building controls for? It's always good practice to start with a master control layer that controls an entire composition. Along with the control layer, you may want controls for smaller components. What are values that will need the most fine-tuned control? Should a control be keyframed instead of keyframing the property directly? Sometimes it's easier to grab a layer in the viewport and move it instead of changing position values on a slider. Evaluate this for each and every control and trim extra controls where possible. Now that we have all the fundamental details, we can start to assemble the rig with expressions. The first portion of the video is played back at about 3 times speed to provide a quicker overview of the rigging process. So here I start the process by parenting the various layers that will end up following each other as the robot moves. So for example, the claws get parented to the wrist, the neck to the body, etc. Then I can add a couple expression sliders to the robot controller to help access those harder to animate elements. This is useful for elements that are not easy to grab in the viewport. Now I can link the claw's rotation to the slider using linear methods. The value rotates about 45 degrees and are reversed for the second claw. Next, I parent the drawer's x-axis movement to the slider so it can easily slide in and out. The slider value is subtracted from the x-axis value, moving it from right to left. Following the drawer is the track. This is a stroke around a path element, so I can link the offset property of that stroke to the rig's x-axis movement. This isn't a perfect solution, but for flat ground, it's good enough. As the X position changes, the offset property slides the track's stroke along the path to give the illusion of movement. As long as the robot is at 100% scale, 1 pixel on X equals 1 pixel offset on the path. Next up is the neck and the arm. These are by far the trickiest part of this rig. So here I want the neck to automatically extend and rotate with the head layer. I'd also like to retain shape layers rather than use something like the beam effect between 2 points. In order to pull this off, 2 things need to happen. Number 1, the neck and the arm's rectangle shape needs to match the distance between the neck and the head anchor points. And 2, the neck layer needs to automatically rotate in the direction of the head layer. Here I can use the length method to achieve the shape's resize. This is applied to the rectangle path dimensions to the x-axis of the rectangle. I can also use the look at method, which points from one 3D point in space to another, and this changes the orientation of the layer to always face the head. When I apply these 2 expressions, the neck will not only extend its size to match the length between the head and the neck, but it will also change the orientation property to point it in the head's direction. Now because all of these properties apply to both the neck and the head, as well as the arm and the wrist, I can apply these same expressions to those properties as well. And finally, I color code the labels to help me quickly see which ones need to be keyframed. The blue layers are locked and the red layers are opened up to reveal properties I need to change. And now I'm going to add some keyframes to the timeline. This part of the video is played back at 20 times the normal speed to provide a quick glimpse into the keyframing process. A lot of this process comes to personal preference and technique. For longer scenes, I tend to do rough blockouts of time for specific actions. So if I need to go from point A to point B and I have X amount of time to get there, those are my known constraints and I start from there. For this scene, however, I keyframed from beginning to end and didn't worry so much about the timing. This scene was created at the tail end of the 400 series, and my main priority was just to have fun with the robot and see what happens. And now I present to you the complete scene. The elements here that use expressions are the neck and the arm length and rotation, the claw rotation, the drawer position, and the track offset. Everything else is still using regular transform keyframes, which demonstrates the balance between automation of the track, neck and arm, and manual methods for the head and body rotation and the claw's position. We've arrived at the end of lesson 407, a quick guide to planning and building your own expressions. If you enjoy this expressions course, consider purchasing the paid content. It includes in-depth documentation, extra tutorial content, high-definition videos, and all the project files used in the training. Your purchase will help to create more free courses like this in the future.